Good morning. Well, we're going to be talking about the black box attacks, protection against them, and we will be discussing the banking hardware security and the trends that we've seen in the past few years. My name is Natalia, and for quite a number of years I've been a reverse engineer with Positive Technologies. First I was responsible for the SCADA security. Now I'm a senior app security analyst. I'm still working with hardware, software, and all the auxiliary systems. Well, I was bold enough to steal a slide from one of the speakers that took the floor last year. It's not been passive-aggressive. Back then they discussed the specifics of talking to the banking hardware vendors. Jumping ahead, I want to say that the software developed, hacked, results in huge reputational risks because no one is going to buy your hardware. Therefore, vendors are not really interested in any public activities, especially when they have to talk about the bugs identified. No, well, it's not surprising, I guess. So we agreed that the cases that I'm going to be discussing with you are going to be anonymized because we don't want to offend anyone. Let's start with some general things. Guys from other industries come to us and ask us how the projects are going on, what's going on from the inside, because from the outside they see some of the strange things that might not be working on the face of it. So I decided to focus on these three pillars. Real case studies in Russia, and actually in Russia in many domains people are quite aware of what pen tests are, what the security audits are. Oftentimes they order services like that, and they order a bundle, which means that it requires a teamwork of experts coming from different walks of life. People are interested not just in scanning for bugs, giving them a report and then leave. They are interested in the specific outcomes. And banking officials want us to do this within the time allocated because we're paid by the hour, so they assist us in any possible way. It might not be true for specific people because they might be afraid that we're going to harm their work, but the top managers say that it's not just to punish people. We're trying to scan for the bugs, not to punish them, but rather to increase the security. Therefore, everyone is highly motivated. Everyone helps us because they believe that we do the right thing. And there are certain specifics when projects are implemented in the banking domain, in banking industry. First and foremost, we do not directly work with vendors, but rather with customers. And the final decision on communicating with the vendors on the bugs identified by us is up to the customer, because the customer pays the money, we sign the report, and without the permission from the customer we can hardly do anything. Another thing is that the hardware that we test is quite expensive, it's difficult to find, and the guys who test the ATMs want to test processing as well. So we go to the site of the customer directly rather than vice versa. The ATM is linked to the processing system, and they usually use ATMs that are being updated because they don't care about them. Like I said, ATMs are quite expensive. There are very few of them, and we don't do anything with the hardware. These are not the attacks that we carry out. We do not take parts of the ATM away with us, and even if we use invasive exploits, we have to get an agreement from the customer first, and we use simulators to double-check everything before we actually launch and exploit attacks. An MOU signed by the vendor and the customer, because some of the attacks might not be possible, and it's up to the customer to identify inadmissible incidents that they want to see, and it's up. If you pay for something, you call the tunes. So it's always up to the customer. However, if we see some bad things that are inherent in the ATM, we inform the customer about that, but we stick to the plan. Now let's focus on the most interesting things. Last year, Positive Technologies implemented several foreign projects, and now we have gained experience of working with foreign foreign customers. And for us as techies, the most difficult thing was that, well, we don't talk to people on the ground a lot, but we still have to do that. And the mentality differences were huge. That was the most terrible thing. We know how to talk to people in Russia. We know what should be said, what should not be said, while when you talk to foreign counterparts, you're not aware of what might cause a problem. And actually, it went both ways. Sometimes we didn't understand why people would say things to us, why would they do certain things. But fortunately for us, we had a rep on the ground, and in both cases, we had local reps who were aware of the local culture, and they would brief us that you should not say this or that, we should go in a different way about that, despite the fact that we knew that we could use this approach in Russia. There was a funny thing. For instance, we were told that we cannot refer to the contract. It so happened that in one case we came on site, and there were 3 different teams working on the ATM in addition to us, and that was a huge number of people. And according to the contract, we had a half a day with the ATM to do whatever we wanted to. And, well, I didn't think that anyone tried to fool us or offend us, and I wouldn't say that they cared so much about the ATM. They had lots of ATMs. But in that particular case, the full-scale audit that our company does was something new, something out of the ordinary, and, you know, some of the contract provisions were not as detailed. I guess it was a miscommunication, but I hope that down the line it's going to be smoother. Another interesting detail I want to share with you. This is the first time we've seen it. In certain countries, jointly with the developers from the bank, they also had experts from the vendors, and the vendors were not too happy about us testing their hardware and identifying various exploits. There were a couple of funny references, but fortunately nothing bad came out of it. So now let's talk about the responsible disclosure and the things that might happen when you talk to vendors. It's not about ATMs alone, it's about the banking system in general. So everyone knows what might be a problem. You know, you get guidelines from Microsoft every single week. Nobody is offended about that. By that, researchers know how to work. They report bugs. They are rectified, and so on and so forth. But however, if in an ideal environment you you identify an incident, and if we report a very complex error which has nothing to do with the joint use of resources, in other words, there are architectural errors that can be hardly rectified, or it might be expensive, or will take too long, and especially if the company is not as large as Microsoft. If we use 90 days and the full disclosure as Google does, it might be a total disaster. And oftentimes we have to be patient while the vendor rectifies the bugs, because it might become a disaster for our customers, because we're a product-focused company. So if we go this way, the customers will not understand our approach. And in industrial, medical, and banking systems, this is what I focus on. So this is what I'm going to be talking about. Updates might be a problem. For instance, it might take up to a year or 2 years to update an entire plant. You have to bench test it, then roll it out, deploy. It takes too long. It's expensive. ATMs are not as problematic. However, it also takes time to develop the updates, send it out to all the customers, make sure that updates have been deployed, that everything is protected, and the vendors might have their own problems. For instance, a developer might have left the team, or the teams might fight with each other. Teamwork might be problematic. Financial problems, just to name a few. And of course, we cannot we cannot say that we are unhappy. It would be more logical to accept the fact that the world is not perfect and then wait for the thumbs up from the vendor. So, but this is a case when the vendor is willing to cooperate. But however, what happens when the vendor does not want you to does not want to meet you halfway? I talked to the guys who were responsible for the banking system security in Positive Technologies, whether they had any funny stories that they wanted to share, and some cases, interesting cases they came across. I'm not talking about ATMs alone. It's about all the banking systems in general. So this is the ranking of the answers I liked. My favorite was one of the vendors said that they didn't care about the vulnerability that might be exploited because that would be a headache for the customer. But we went via CERT, Computer Emergency Response Team, and the vendor had to rectify the vulnerability. People would also ignore our letters. This is especially true for U.S. vendors for political reasons, I guess. Why tell everyone? Because we already rectified the problem. The vulnerability is no longer there. Good job. Bye. Some of the customers focus on the vulnerabilities and critical vulnerabilities before they deploy an update. They might say that the update is not as important as the vulnerability, and they might delay the rollout of the update, which means that the protection will go down. And the fourth bullet, which is bad for the researchers, the vendors would get a report, but they would say that they were the ones who detected the vulnerability rather than researchers. It's quite suspicious that they would be staying silent for 2 months in a row. Let's get down to earth, and I suggest we discuss what's inside the ATM first. We might have people in the room who have never come across an ATM, and there's a hypothesis saying that this is what the inside of the ATM looks like, you might find some proof of that. Unfortunately, what you will find inside an ATM is a set of various devices. An ATM is split into two parts: a vault with the printer with cameras, pin pad, and the central processor that manages all these devices and provides the beautiful images for the customers. The vault is at the bottom of the ATM. It's made of a strong metal. It is protected by a great door with a great lock, and there are several cartridges inside. And by the way, the dispenser and the validator with the cartridges are in the vault, but this is not always the case. And this is an image, a cross-section of an ATM. Hold on a second, let me activate a laser pointer. I hope you can see it on the image. The resolution is not good enough, so I'll just use my hand. These are the partitions. This is the vault part, and the modules, the printers, and all the other devices are on top of the vault. The dispenser basically dispenses the bills. It activates the cartridges, the automatic systems, and so on and so forth. I will also use the recirculation module term. It includes the dispenser, the validator, and the cartridges, as well as the presenter. And the ATM allows you to also feed in the bills into the vault. And when you ask what you need to withdraw some cash, so you go down the list to the dispenser and the processing center. We don't need every single detail about the ATM to discharge the task. And this article from our company answers the very popular question. A bank has multiple ATMs, but on top of the ATM, they have their own interface. Does that mean that they program every single one of them. Actually, there is MSXFX, which is a library. It's an intermediary between the software by the vendor and the bank. I think you will see it better on the other screen. So it's an Express Manager, if I'm not mistaken. That's the title used on the screen. So the vendor has an intermediate layer between the hardware and while the bank in its turn uses the products of our company to develop their own ATMs, and they tailor-make this part of the ATM. The software gets in touch with the vendor's software through the standardized API. Now let's talk about the way such systems can be attacked. The classification has been covered several times, so I'm just going to repeat this diagram. I didn't see any standard one online. So let's go over the main parts of this diagram. Brute force attacks. Of course, it's not part of the bundle of services that we provide. However, if we did, then the projects would be way more interesting. Fraud is not that complicated technically wise, and our experts are not required because banks are proficient in solving that on your own. We focus primarily on the cybersecurity threats and cybersecurity attacks. And of course, if there are several links in cooperation, you can attack various levels using various means. And in our article, there was a great image showing the various points of contact on the attack surface. Online network equipment, pen tests, and we as an invited reverse force primarily focus on black box attacks. And as is clear from this diagram, the attack is carried out on the hardware, giving the physical access to the ATM. So we have more questions than answers. How come dispensers and recirculation modules are not shown? You have to go inside the ATM. Why would you research something that you cannot get physical access to? And you might recall that I only mentioned the vault as the higher protection level part of the ATM. The rest of the ATM is not well protected because the metal is very thin. There are various plastic cover the holes that you can use. And online you can see lots of images with holes drilled in the front panel. The keys are very simple, and they can be bought on eBay. One of the researchers said that he would open up the lock by using a piece of wire through the back panel, and it was really funny to see that. And customers usually don't force us to do that. We just identify the way adversaries can get access to the ATM for the black box attack, to make the ATM dispense the bills. And validators can be attacked, but our projects are really short in time, and we only focus on the priority points of attack, which is the dispenser. We go to the device level, so firewalls, antiviral software do not help at this hardware level. They are not effective. Well, I talked about the access to the cabinet. You can use cables and hubs to launch your black box attacks. ATMs are about the convenience of getting a service because many people withdraw money from the ATMs. So our main task is to identify vulnerabilities at the hardware level. Oftentimes, it makes more sense not to go through the firmware, but rather through the software of the vendor. You can use logs or characters to launch an attack. For instance, vendor just provides you a hardware or coded line, and this is it. However, to detect the vulnerabilities, we need to launch a full-scale pen test. It could be part of the file system. The vendor has to update the software modules for the ATM. Social engineering might be a way. For instance, ask the software engineer what's inside. You can go to the forums, Black Hat forums, and memory sticks were bought on Alibaba to get access to the ATMs. So, as for the vulnerabilities that can be found in the dispensers and recyclers firmware, frankly speaking, basically they're the same as for other pieces of hardware. For instance, binary vulnerabilities, Stack Overflow vulnerabilities, and I don't think I'm going to share anything new with you if I talk about binary vulnerabilities, so I'll focus on other scenarios. For instance, encryption, but the implementation might be bad. Logical vulnerabilities are often the problem, and the functionality becomes available while it shouldn't. It might not be interesting for the reverse engineer, but they are more elegant and they don't cause as much damage as binary vulnerabilities, which is good, especially given the fact that we work for customers who don't want us to switch their ATMs off. How do we protect the devices? The level of protection is increasing as the time goes. About 8 years ago, I would focus on a communication protocol of a dispenser. Everything was quite simple. All you needed to do was send a code with a signature, and it also contained additional options that could be tailor-made. The control sum, and you withdraw a cache. You don't see any encryption, no signature. This is no longer the case, because developers stick to certain principles as for the ATM communications are concerned. And actually, this is an exhaustive list of the ways to protect your ATMs against black box attacks. At least people try to use all these means of protection. However, there is still a policy in place that in Russian everything is protected through fuzziness, and it's difficult to research systems like that. Everything is hidden from the curious people, and it's not always that we ensure highly effective protection. This principle, the reasons for this principle being bad were stated 100 years ago. Don't think that no one would ever get access to your code. You can buy an ATM, you can buy part of an ATM, you can get the firmware from the bought ATM. You can come up with other ways. Imagination is your limit. And I would say that if a potential adversary, when getting the firmware, understand that this is not a way to attack, or it's too complicated to attack, they might come up with new things. However, to ensure high protection level for the ATM, the process is slow, but the protection levels are going up, so there is still much job to be done by the researchers. Well, finally, let me share with you these two cases. As mentioned, the vendors and we agreed that both cases would be anonymized so that they are not mentioned. I think that these two references would still be valuable for training purposes. Right, so we were sent away, and the preliminary analysis identified a firmware file on the hard disk. The two ATMs were quite similar, and the firmware was the same, but the vendor logs stated that the recirculation model in the second ATM used a different version of the firmware, not the one mentioned in the titles. But we were lucky. It was just a simple memory stick, and we used the firmware. We download the dump. So to stay on the safe side, use different ways to get the firmware. Otherwise, you might see that it's a different version. By the way, a couple of times people from the outside of the industry ask me whether it's difficult for ladies to work in this domain. There are two reasons which it might be difficult, you know. And the first one is the following. When you try to read the memory, what you do is you have to squeeze this device and you put the clamp on the memory stick. It's it's very tough, and you should use your second hand to operate the software, and it takes quite some time. So oftentimes it took us several tries. Now we have automatic clamps that we bought on AliExpress. Now you can do this without anyone's help. The second problem was that the chips on ATMs are oftentimes protected by metal strips that are bolted down, and I was not physically strong enough to unbolt these strips. But last year we bought an electric screwdriver, and now I can unscrew everything on my own without asking males for help. So going back to the case study. This is a programmer that we removed, and the reverse engineers can double-check the firmware by 40H bytes. I think this screen is way better in terms of quality of the image. If you can do that, then you are a good reverse engineer. The basic address was something that we didn't have to look for. We didn't have to go into data sheets on the microchip. It was specified in the file headers, in the updates. It was identified as Redux, but it was curbed. It might have been obsolete because the code was very short. We didn't know what the precise version was, and some of the functions were totally removed. And by signatures, we quickly identified the version of the firmware. The signatures are shown on top of the slide. There are traffic lights, as you can see. Mutex might have the same signatures. Anyway, we used them to identify the version of the firmware. So we identified the operating system. Then it took us a short time to find the links between the tasks. And then when we analyzed the firmware, we're interested in how the device communicates with the outside world. We had OAuth and USB managers, and they would address relevant memory domains. Well, you can use different ways. How did we know which one we needed? The communication vector hinted that it might have been the USB hub. The logs from the USB hub and the USB traffic were found in the USB backup, and that was a sign that something was happening via the USB connection. So we decided to dismantle the USB connection. And when we analyzed that, it turned out that the dispenser set the connection, then used the inscription, and the communication protocol helped us identify the following interesting thing. This is just a data set that was coded, then encoded, and these are the values that we saw. And then it adds two more hardware characters for authentication that were matched by the random access memory. The recycling unit generated another value via mathematical algorithms, then codes the same line, and then the recycling unit generated the same key, the same encryption key. To make sure that everything went fine, it sent an encrypted message with a common key based on the previous messages, and if there is a match, then it grants access to all the commands in the recycling unit. So the question is, what prevents me from doing the same thing that the computer did? You can the hard-coded values are temporary ones, which means that I can use any value. And for demonstration purposes, in the script, I did not generate them; I just hard-coded them. So which means that there was an attempt to establish protected communications, but because of the open keys, it turned out to be problematic. So as an outcome, as I mentioned, I sent the data via the safe link. I used the values that I received from the recycling unit, and then by using the very same algorithm, I generated the key, exchanged the certificate, and then send a command to withdraw the cache to demonstrate the vulnerability to the customer. We also use more complicated vectors for random codes. We also analyze the firmware updates. So I analyzed the command for the firmware update, and the header was double-check the updates. The file signatures were different for different devices, and to make sure that the right update arrived at the right device, I analyzed the size of the file and the sum total to make sure that that was the full update for the device. In other words, there were no obstacle to generate and upload your own update file. And of course, we reported all of that to the vendor, and as far as I know, the safe link was updated considerably, the key generation algorithm was changed, and they also encoded the firmware. And the last thing was done for me not to be able to analyze their system anymore. And one of the vendors asked us to retest the file, and the vendor obfuscated the report lines because the Python code was 15 lines long, but it was still unpleasant. In this particular case, everything was fine, so let's move on to the second reference. This is an ATM that Denis Goroshev and I had to analyze very quickly. This is a photo coming from his presentation he delivered last year. He says this is the way he looks. Before we flew off, like I said, it was a foreign flight. We analyzed the firmware in advance. And the dispenser chip had a processor, a central processor with a very rare architecture, so we read up for that. And when we arrived on site, it turned out that after 2022, the firmware used by the ATM was based on the ARM processor, so the firmware turned out to be totally different from the one we expected, but we quickly found it in one of the file sharing systems. We came across the ATMs by this vendor quite a lot, and we knew where to look for such firmware. And Denis's updates turned out to be quite useful. He came across a vector like that, but there were no vulnerabilities in this ATM for cash withdrawal. But we had to do something, right? Because we could not disgrace the company. So we set up the communication protocol, and it turned out that for authentication purposes they used 3DES-MAC or DES-MAC, and the session key was generated by by another piece of software. And after each successful transaction, the key would be changed. The 3DES-MAC generated code, the message, the secret, and the salt. So only when the vault was opened, they would be rendered ineffective, which wouldn't make any sense for the intruders. For DES-MAC, we saw that it was not hard-coded, and by default, it used the 3DES-MAC. So our dreams did not come true. As for algorithm selection, the code showed us that the MAC mode variable had a very interesting option. You could set it to 0 and disguise the attack as a device. It was just a global value for us in that particular case. So these are the interesting facts that we learned from that particular project. The MAC authentication was not required to change the session key. The whole set of settings was changed, and the current key was obtained. When the session DESMAC key was changed, the ATM should not be in the serviceable mode. The vault should be closed. In other words, it's just it should be out of order. And the algorithm used should not be DESMAC or DESMAC with the disabled function for the device attack. So now follow my thought. We analyzed the structure for the message to withdraw the cash. We changed the MAC mode. We set it at 2 so that the condition is met. Then we updated the session key for the MAC mode with a special command, and we send a message to generate a session key. The key itself was based on the master key on DESMAC, and then the same message would be used to well, how do I put it? To be sent to the hard-coded line. In the recycling mode, double-checked the hard code with the new session key that should coincide with the new value, and that was the way to test the master key. Then we set the mode to 1. We asked for the value of the secret key and sent the cache withdrawal command, and so that was the way that we bypassed the protection system. And as far as I understand, the vendor rectified the problem, removed the vulnerability by updating the firmware. Nothing else to add. It was a success story. So as for the takeaways, the level of protection of banking system is increasing, but there is always room for improvement. Collaboration with vendors is also improving, and all the cases that I shared with you are quite old, which means that we can improve the cybersecurity of banking systems, and we as researchers will be able to research a longer list of hardware, including ATMs. And I really hope that these researches will no longer be a priority sometime down the line. And I'd like to thank Denis Gorishev and Andrei Sevastianov, who were my co-workers as part of all the projects. They were a great team. I'd like to thank Diana Dorahmanova, Yaroslav Golovanov, and Alina Klinchikova, because but for their legal expertise, this presentation would not be possible. I'd like to thank the app analysis department and the banking system security research department, because they always assisted us whenever we asked them. Thank you, guys. And I would also like to thank the guys for setting up their own independent technical track, which is a great thing for our ever-changing world. I'd like to thank you for your attention.